Good morning, students. Today I am going to explain unit number 2, programming of 8085 processor. In unit number 2, there are 6 topics are available. First topic is instruction format. Second topic is assembly language format. Third, addressing mode. Fourth one, instructions. Fifth one, instruction set. Sixth one, sample programs. First, we can see about what is meant by instruction format. In 8085 instructions, there are 3 types. One is called as 1-byte instruction. Second one is 2-byte instruction. Another one is 3-byte instruction. The total instructions are classified into 3 types: 1 byte, 2 byte, and 3 byte. What is meant by 1 byte? First, add B, sub C, complement the accumulator content, compare C. These 4 instructions, example, these 4 instructions are called as 1-byte instruction because it has only opcode. It has only opcode, so it is called as 1-byte instruction. Add B, the opcode is called as 80. 80 is an hexadecimal number. It is called as an 1 byte. So 8 bit is called as 1 byte. So if you write the binary, the value is 100000. Subtract C, the opcode is 91. Complement the accumulator, the opcode is 2F. So this is called as 1 byte instruction. So 1 byte instruction, it is as only opcode. Second type is 2 byte instruction. In 2 byte instruction, I have given 3 examples. One is called as move immediate. Another one is addition, another one is subtraction. MVI B,05. This instruction, it has 2 bytes. One is called as 06 is 1 byte, 05 is another 1 byte. So it is called as 2 byte instruction. In 2 byte instruction, it has 1 opcode and 1 operand. 06 is called as opcode, 05 is called as operand. The first byte is called as opcode, second one is called as operand. Second instruction, ADI04. This instruction also called as 2 byte instruction. 06 is called as opcode, 04 is called as operand. This is operand is called as an 8-bit data or address. Next, we are going to see about 3 byte instruction. First instruction is LXIH4500. 21 is called as an opcode, 00 is called as lower byte address, 45 is called as the higher byte address. So 1 opcode and 2 operands, so it is called as a 3 byte instruction. Next, store STA 5000. It will store the accumulator content in the memory location. 5000 is a memory location. In that, 00 is called as lower byte address, 50 is called as a higher byte address, or LSB address or MSB address. So this instruction consists of 32 is called as opcode. Plus 00 is called as operand. 50 is called as operand. So 3 byte instruction means opcode, lower byte data or address, and next one is higher byte data or address. Opcode, operand 1, operand 2. It is called as a 3 byte instruction. Next, we are going to see about assembly language format. In assembly language format, I'm going to explain with one small example. JNZ. So this is called as one instruction. So this is called as assembly language instruction. That is called as mnemonics. JNZ is called as an instruction. It is called as an assembly language instruction. It is named as mnemonics. For this instruction, you are writing commands. What is meant by command means, this instruction, it will check the 0 flag. If it is not 0, it will move to this memory location 5000. Otherwise, it is moved to the next memory location. That is the command for this instruction. Next, what is meant by opcode? The microprocessor, it will not understand this machine language. So this will not understand your assembly language. So you have to write the program in the machine language. So opcode is called as an operation code. It is called as a machine language. So every instruction has one assembly language and machine language. Machine language is called as operation code, and assembly language is called as mnemonics, or user can understand the assembly language only. Next, what is meant by operands? So operand is called as an used additional information. It is an 16-bit value or data or address, or 8-bit value or 8-bit address. So here it is an additional information is given, that is called as a 16-bit address. Next one is label. The label is used in the program as a reference for memory location. So this is the format of assembly language. Next, I am going to explain about addressing mode. What is meant by addressing mode? So in microprocessor, we can access the data from memory, we can access the data from input device, we can access the data from registers, we can access the data from output device, etc. So the different way of accessing the data by the microprocessor is called as addressing mode. We can write the data or we can read the data. So if you take an example, a memory, RAM. So from the RAM, we can read the data and we can write the data. Registers, we can read the data and we can write the data. Input device means only we can read the data. Output device means we can write the data. So addressing mode means the different way of accessing the data by the microprocessor. It is classified into 3 types. One is register to register, data transfer takes place between register to register. Next one is memory to register. Another one is called as an register to memory. There are 5 types of addressing mode. First one, it is called as immediate addressing mode. Second one, it is called as register addressing mode. Third one, it is called as direct addressing mode. Fourth one, indirect addressing mode. Fifth one, implied addressing mode. First, we can see about what is meant by immediate addressing mode. Example, MVI E, AB. AB is called as one data. This data will immediately move to the E register. MVI means move immediate. This I represents, it is called as an immediate instruction. So immediately this will move the 8-bit value to E register. So this comes under immediate addressing mode. ADI 050. 50 is an 8-bit data. It will add the data immediately with the accumulator and store the result in the accumulator. So it is called as immediate addressing mode. So we can take 50 is an 8-bit data. Next, if you see LXID means 16-bit data. This data immediately it will load in the DE register pair. So the immediate operation will take place. So that is called as immediate addressing mode. Next one is register addressing mode. Move A, B. The B register content, I am going to move to A register. So here the data transfer takes place between 2 registers. So it is called as register addressing mode. Next, move E, H. H register content, I am moving to E register. Add C. Add C means A register content and C register content both will be added and the result will be stored in A register. So here only the registers are involved. So it is called as register addressing mode. Data transfer takes place between 2 registers. Next one is direct addressing mode. So example, LDA 3000. So LDA 3000 means the data stored in the memory location 3000. It is immediate. It is loaded in the accumulator. Next, STA 5000 means store the accumulator content in this memory location. Here, I am going to store one data from register to memory. So the memory address is directly given. Next, LDA 3000 means memory to register data transfer. So here memory address is directly given. So it is called as direct addressing mode. Next one is register indirect addressing mode. We can see example move A comma M. From M means memory pointer or memory address or data HL register pair or data pointer. M represents the memory pointer or data pointer. From this memory address, I'm going to move the data to register, from memory to register. But here, the memory address is directly, it is not given directly. So it is called as indirect addressing mode. Next, example, move E comma M. So memory data is transferred to E register, but the address is not given directly. Move M comma C. The C register content is moved to the memory. So memory address is not given directly. So these are called as indirect register addressing mode. Next one is called as implied addressing mode. So in the previous topic we have studied there are three types of instruction. One is called as 1 byte instruction, 2 byte instruction and 3 byte instruction. So the 1 byte instructions are called as implied addressing mode. Why it is called as implied addressing mode means these instructions consist of only opcode. There is no operand. So CMA means complement accumulator, rotate accumulator left, add B, sub C. The instructions, example, these instructions consist of only opcode. So it is called as implied addressing